so I will not go to the final exam. All right, so coterminal angles. Okay, we're going to say that two angles are coterminal. If they have the same terminal arm on the circle. Okay, so I'm going to ask Chris here because I know she plays basketball. Okay. So I don't know if you know this, Chris, but I'm next to slam dunker. At least I used to be. So this example will deal with coterminal angles here. So Chris and I are going to play basketball, but I'm going to slam dunk on her because I'm cool like that. So I'm going to rotate under her and I'm going to dunk on her at 40 degrees. Okay. I also have so many great hops that I can dunk on her many different ways. How else can I spin and dunk on her other than just 40 degrees like this? What else can I do? Yeah. Like, what if I do this to her? Whoa, whoa, whoa. What's going to happen? How many degrees would that be? Right? How'd you get that? Sort of? 360 plus 4 is 400. Okay. So have you ever seen on TV, like skateboarders, and they go, yeah, I'm doing like a kick flip 720. What's a kick flip 720 going to be? Yeah. 3 spins. 2, but yeah, okay, 2 spins around me, okay? So the whole idea is, though, as long as it's the same position, if I go 40 degrees or I go 400, right, it doesn't matter, I'm still in the same position. How else can I get there other than 40 and 400? That's right. Not negative 40. Negative 40 is going to send me over this way. So negative 40, I like your triangle. Negative 320. Okay, negative 40 will let me here, but negative 320 will spin the other way to spin back this way. Okay? So what I'm trying to say for this for coterminal angles, I'm glad nobody said like 8,000 degrees made me spin. Okay, fine. Okay, because they used to do this to me when I started teaching. The idea is if you're adding or subtracting them all, go 360. That's the idea. Okay, so to get this. All right, and we're going to say here to add on here the principal angle. Is okay. Back to the main again here for a sec. So somebody try and translate what that actually means in English. Because we'll go back to main for a sec. Matt, you want to take that? It's half a hand. Raise, go ahead.
Theta is less than, no, 0 degrees is less than or equal to theta.
Yeah.
Which is less than or equal to theta.
Very good. Awesome.
Theta is between 0 and 3.
And that's how I was going to write it down. So theta is between 0 and 360. Okay. So basically, what I'm saying for a principal angle, it's like one rotation. It's in the middle. It's in the, you know. Okay. Here we go. So, example 1. We're on example 1, example 2. So if theta is bigger than 360, how would you make it between 0 and 360? Sorry? Subtract 360 from it, okay? So again, I'm going to do an example right now I got. So example 2 is going to say, determine the principal angle and 3 coterminal angles. Excuse me. For theta equals 500. So this is the question that Chris was asking there. Okay, what if your angle's on the outside of 0 to 360? Okay, so let's think about coterminal works. How am I going to get another angle that's coterminal to 500 degrees? What do I do? Yeah, Matt, go ahead. 500 minus 360, okay? So you can add or subtract multiple 360. So if I go minus 360, I should get theta equals 140. So somebody tell me why this is the principal angle right there. Play along, please. Yes. Yes, okay, good, but why is that a principal angle? I need to tone it down a little bit here. Why is that a principal angle, Matt?
Because 140 between 0 and 360.
Right on. Okay, right. That's like within one revolution. So when you were talking about drawing this loop on your circle here, like there's no like messy loops, right? Like just like your base angle. So somebody tell me another coterminal angle to 500. Similar than that. Play along, please. Please play along. No one's playing along. This is why Spider-Man comes in. What's another angle coterminal to 500? Yeah, go ahead. You subtract another 360, good. So if I subtract 360 from here, I get, what is that, negative, I can do that, 220. Someone confirm that for me? That's confirmed, yes, I think. Nobody's talking, is that right? Oh, guys, nobody can subtract it now. I know it's really dismissal, but you're never been dismissed yet. Okay, let's get another coterminal angle, please, to 500. Go ahead. Charlie, go ahead. Good. How'd you get that? Very good. So here we can add, which is, what was it, 860. Now, some people, when I first started teaching, were crazy. It's the same person that we spin around 25 times. You could actually, if you want to, plus 25 times 360, right? Any multiple of 360 you could do, right? So as long as what that would be, I'm only going to demonstrate once, okay? So instead of doing this, I want to spin 1, 2, you know what I mean? And the angles would keep on going for the angle, so it would be a huge angle. Okay, it's still going to be within because the angle, like as you're looking around the circle, right? It's always going to be in there, right? But the angle is going to be on the opposite side. Yes.
So it's like irrational fractions where you have like crazy high numbers. You don't need them; they exist, but they're useless.
No, they're not. These aren't useless at all. These ones totally aren't useless at all. Yes.
2300.
So that's plus. That's all together. 2300.
Yeah. Yeah, equals 5.
We'll go with it going. Okay.
Yeah.
So again, but the idea is you can spin around many times. Yes. Principal angle again is going to be the one between 0 and 360. So what? Back to this example over here. We were showing Matt made a good comment. He said, okay, well this is 405. Okay, but Matt said, okay, well that's the same as 45 degrees, right? So if that's 405, I can say this little part right here is 45 degrees. So the principal angle to this would be 45. The overall angle is 405, but it looks like 45. That's what it's going to be. Okay, so it's like the smallest angle that works. All right, I have one more example that I think we're going to stop. Okay, example 3. Please put a star beside this question. Okay, example 3 says, please plot the point -4 on the 1 on a graph. Find the principal angle. Okay, so take a second here and scribble that down. I want to go into this in great detail to make sure it's completely understood, because this again is a foundational question for the rest of this course. Yes? Yes. Yes. No, not this point right here, right? But when we get to graph, sine and cos, yes. Like the multiplying like this will be very important, like what we just did here. Right, Matt, would it fair to say that's what we're doing here as well, as important? All right, so let's do a quick little graph. This is going to be the messiest graph I've ever seen. This does not have to be a beautiful graph, okay? Because if you're interested in the math, not to be a good graph, okay? So here, I'm going to do negative 4, comma 1. Something like this. There's 1, 2, 3, 4. And there's my point, which is negative 4, comma 1. Okay, so that's all it says to do. It says to find the principal angle. Now, this is where if you are fading out and wishing it was 1:30, whatever time this day ends, you need to fade in here. It says find the principal angle. I see no theta anywhere in this question. Can someone be brave and try and tell me what angle I need to find? Yes.
The center to the point in the line.
Good. Okay, you do need to have that as a line. That's wonderful. Okay, well, where's theta going to be? Good, Scott? Yeah, good. So this is going to be theta right here, sort of like this. That big angle. Okay. Now, I still have no idea how this is going to happen. That's correct, by the way. Wonderful job. Okay. But I still have no idea. Can someone think of a suggestion using grade 10 math of how I can solve that one? Yeah, go ahead. Sorry? Yeah. Good. So what you can do is you can either use the top triangle, which I'll do in blue, and then you can find this little angle there, okay, and then 90 plus that, or I can use the bottom angle and do 181. So I'm going to use the top triangle if you don't mind. So I'm going to zoom in here, do something like this, and call that beta, and then say that theta equals 90 plus beta. Okay, now, this is fundamentally, foundationally important to this. Are we okay on what just happened there? Okay, so what I'm doing is I'm ignoring this side of the graph, right? So I'm just going to solve this blue angle right here. When I have that, I add it to 90, and that's going to be the entire big angle. Okay? Are we okay on what happened there? Okay. Now for the dimension of the triangle. What's the top length going to be? Okay? 4. Okay, we use length, so it's going to be positive. So it's going to be a 4. And the height is going to be 1. Good. I'm going to solve for beta. Now I know what you're thinking. You're saying, I want to use sine law. Don't use sine law for this, please. Right? How am I going to solve for beta, please? Pythagorean theorem? No, that's not for angles. That's only for side. That's okay. Sine law? No, don't use sine law. Sorry? Don't use cosine law either. You could, but I wouldn't. Oh my goodness. Skylar? SOHCAHTOA would be beautiful, in fact. Wonderful. Fabulous. Okay, so what am I using here? Sine or cos or tan? I'm using sine or cos or tan in this case? Tan, okay? So I'm going to say tan beta equals 4 over 1, which is fine. Can someone remind us, please? I'm going to pick on you, Julia. How do you solve for beta here right now, please? Inverse tan, good. So beta equals tan inverse of 4. Now I'd like everyone, I want to give you a second to actually calculate that yourself. Give everyone a second to do it before you give me the answer here. Okay. Now looking at my triangle, it should be an answer between 0 and 90. Look, I'm guessing it'll be like 60, 70, like in that range. And it looks like, according to my diagram, okay, I don't know if my diagram how accurate it is, okay, but it should be a relatively big angle, it looks like. Luke, what'd you get for an angle, please?
75.
75 point? 75.96, 76.0, I'm going to call it. That's okay. Okay, great. Now the problem is that isn't a 76-degree angle, though this one is, but the entire theta is.
How did you change the mode of my camera? For some reason it's
Okay, so, I think it's just. Oh, TRG. Please make sure as we're in the trig here that you're in degrees, right? There's one question on how to change your calculator. So it should say DEG. If you're unable to get 76, that's what happened. To get my beta, then I'm going to move this to my theta. I'm gonna say theta is, equal to then 976 is what, 166.0? Okay. And again, looking at my rough graph, that sort of makes sense, right? Like this little sliver then would only be 14, because 180 is a straight line, and that's sort of equal to me, yes?
So when you add the theta and 90 or whatever, if you were to get 500 and something, you would just
Yeah, exactly, yeah. And we'll deal with all that stuff, like today this is nice, this is meant to be small, but yeah, theoretically, if you're gonna get messy answers like that, yeah, you totally do that, yeah.
So, you can just keep adding 90 for each quadrant you ask them.
And I'll give you guys one more to try before we go here, and yourself here. I'm sure you're just coming in. Some girls should do it. And Dean was doing this tonight. You guys laugh, okay? It's all right, example 4. Example 4. Find the principal angle. Okay, I'm going to pause the video. I want you to try this. It's just like the last one with different numbers. You can do this. Okay?